Let's rewind to the Cold War. The UGM-27 Polaris missile was the first submarine-launched ballistic missile, a keystone of the U.S. nuclear deterrence. Its guidance system, packed with analog computing modules, and deep inside those modules lived the R212 transistor. The R212 was a germanium PNP alloy-junction transistor co-manufactured by Texas Instruments and Tung-Sol. These weren't just parts, they were mission-critical components hand-selected for reliability in underwater launch and space conditions. There were two main variants, as you can see here. The later TI version with the stubby gold metal can and laser etch markings, and this early Tung-Sol version with powder blue coating and a stamped ID. Both were built to mil-spec standards, often batch tested for missile-grade performance. As you can see from this unused Tung-Sol, it's built like a tank, made to withstand almost anything. Let's see how the 65-year-old germanium transistor works today. Looks like it's working just fine, but I think I'm going to try to find one that's not working and see if we can crack it open. I found one that tested bad. This guy's tough, but I don't want to damage the inside, so I'll be very gentle. Try to get to it layer by layer. I got it open without much damage. Now let's take a look inside. Here you'll find classic alloy junction layout, but here's the twist. The germanium slug has a literal hole bored through it. It's not damaged, that's intentional. This through hole allowed precise placement of the indium alloy beads for emitter and collector. It's a rare architecture, almost like threading the junction through a needle. The geometry helps stabilize thermal behavior and reduce leakage, critical for analog signal fidelity. Collectors prize the R212 for the Cold War pedigree, but I bet very few people know about its unusual construction. I'd love to hear your comments, and please take a second to subscribe to Real Space Junk.